Example, consider the following statements. Sine of alpha equals 3/5, where alpha is in between pi over 2 and pi, and sine of beta equals negative 1/7, where beta is between 3 pi over 2 and 2 pi. So we are being asked to determine the exact value of the following expressions, and we will see that we'll use these sine and cosine sum and difference identities on the last couple parts. So first it's asking us to find cosine of alpha. And what we're given is that we know sine of alpha, and we know that alpha is in between pi and pi over 2. Okay, so let's do that. So we can draw some type of diagram, is always helpful here. And we are going to say, let's see, sine of alpha is 3/5, and I am in quadrant 2. Okay. So if I'm in quadrant 2, I'm going to use the fact that sine of alpha is 3/5. I want to think about this with those generalized trigonometric definitions where I'm on some circle of radius r. And in this case, sine of alpha would be y over r. So 3 is my y and 5 is my r. And so if that's the case, I can think about where my point might be. Let's see. So maybe it's somewhere like this, where my radius is 5, and my point that it extends to is kind of blank, don't know it yet, comma 3. Okay, and this is my angle alpha. And then it creates this kind of nice right triangle down here where 3 is the side length there. And I want to solve for this side length down here on the horizontal axis because it's going to give me information about my x value. Okay. So to do that, I'm going to solve for, I can just call this, a or something, and I'll go ahead and solve for that. So when I do that, I get 3 squared plus a squared equals 5 squared. So a squared is 25 minus 9. A squared is 16. So I'm going to say a is the positive. A could be plus or negative. I'm going to say a equals 4 because I want to use a positive value for the length of a side. But I also know that a is going to give me information about what my x value is. Well, my x value is either going to be positive or negative a. But because I'm in quadrant 2, I need to pick negative 4 for my value of x. And so now I have x, y, and r, right? So I have x, y, and r. And so if I want cosine of alpha, well, cosine of alpha is just going to be x over r, and x I just solved for is negative 4, and r is just 5, so this is just negative 4/5. So I found that part. All right, let's do the same thing for cosine of beta. We have sine of beta is negative 1/7, and beta is between 3 pi over 2 and 2 pi. So this information tells me I'm in quadrant 4, just like this information for alpha told me that I was in quadrant 2. All right, so let's make another picture. It's the same kind of thing where I am wanting to make some kind of drawing, and sometimes it helps me to just write out what I have here. I'm given that sine of beta is equal to negative 1 over 7. I'm going to write that as negative 1 all over 7 because I know my value of r, the radius of the circle that my point is on, is just always going to be positive, and then my y here is going to be negative. So draw that down here in quadrant 4. So again, sometimes it helps to maybe draw the circle. I'll draw the circle for the one up here. Right, we are on a circle with radius 5, and here we're on a circle of radius 7. was not my best circle. Here we go. The radius is 7. Um, and then this length here, sometimes it's helpful to draw the triangle kind of like out away from your circle because it gets a little crowded. So 7 is the radius. I have a right angle. My angle is beta, so I'm going to draw that in here. Here's beta. Okay. Technically, the angle inside the triangle here is beta prime, which is the reference angle for beta. The length of all of the sides of the triangle should be positive. So even though I'm going down to the point blank comma -1, I'm saying that this length here is the absolute value of -1, which is 1. So now I want to solve for that x value. Now, again, I often use different labels for the x value and the side of the triangle because the side of the triangle always has to be positive and the x coordinate may or may not be positive. So I could call this d or something like that. So I'm going to solve for d. So now d squared plus 1 squared, 7 squared. D squared is 49, take away 1 is 48. The square root of 48 is just 4 root 3. Okay. Now, d is always positive because it's a side length, but what would x be in this quadrant? It depends on which way I'm moving along the horizontal axis, right? I'm moving to the right. So my x value is going to be just a regular 4 root 3. So 4 root 3 for my x value. So did I find all the values I needed? Yes. Here's my x, here's my y, and here is my r. So I've got everybody. Now, why is that helpful? Well, because cosine of beta is defined as x over r. And so x over r is 4 root 3 over r, which is 7. Now, if I want to find cosine of alpha plus beta, well, notice I haven't even figured out what alpha and beta are, right? I haven't figured out those as actual angles. But I can still figure out what cosine of alpha plus beta is based on these formulas. So cosine of alpha plus beta. Okay, so first I'm going to do is write out the formula. So that's cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, well, do I know any of these pieces? Well, I know all of these pieces, right? 2 of them are given to me, 2 of them I just solved for. So cosine of alpha was -4/5. Cosine of beta is 4 root 3 over 7. Sine of alpha, all right, that was given to me, but let's go up and remind ourselves, 3/5. Sine of beta, -1/7. So now what I'm going to do is just multiply this out. I get -16 root 3 over 35 plus 3 over 35. So I can write that as 3 minus 16 root 3 all over 35. All right. Now what about sine of alpha plus beta? Well, no surprise there. We're just going to use our formula. Okay, so what do I get? I get sine of alpha, cosine beta, plus cosine alpha, sine beta. So there's my formula, and now I'm just, as we say in the biz, plugging and chugging. All right, so sine of alpha we said was 3/5. Cosine beta, let's see, that was 4 root 3 over 7. Cosine of alpha, that was, let me just, -4/5. And sine beta is -1/7. And that just gives me 12 root 3 over 35 plus 4 over 35. And so I can just write that as one term here, 12 root 3 over 4 all over 35. So we get this nice practice of given either the sine or cosine value. Here we're given sine value and the quadrant, and we're able to find the cosine value. And here I just use my trig formulas where I can define sine and cosine just based on an angle and point on a circle of radius r. Once I found cosine of alpha and cosine of beta, then I have kind of these 4 pieces. So I can find things like cosine of alpha plus beta and sine of alpha plus beta, even though I didn't know, or I don't know, what alpha and beta actually are.